Well, let's look at number 9, which asks us to find the volume of the solid generated by revolving the region bounded by the graphs of these equations about the x-axis. So I've graphed this on my calculator, and we're going to look from -4 to -2, and this is the region we're going to rotate around and find a solid of revolution. And the volume of that solid is what we're asked to find. So the first thing that I'm going to do is to find the volume of the solid rotating only the line about the x-axis. And so we would do that by one possible way that we could do that is to use the definite integral from -4 to -2 of pi times the function, in this case 5 squared, with respect to x. Okay, and we'll just get 25 pi x, 25 pi x, and then we're evaluating that from -4 to -2. Okay, and we get around 157.1 if I round to one place. Either leave it on your calculator, write it in exact form right now, or round out kind of farther than you typically would. Well, next we're going to find the volume of the solid generated by rotating the curve 3 over x plus 5 about the x-axis. And that'll be the definite integral from -4 to -2 of pi times this function, 3 over x plus 5 squared dx. And when I square this, I could either think about it as square the 3, square the x plus 5 if you want to do that right now, or you could write x plus 5 to the negative first and square it then. Either way, you're probably going to end up using negative exponents at some point. Okay, so if I write it now as 9 over the quantity x plus 5 squared, and then convert, we can now find the antiderivative. And so I have 9 pi. The antiderivative of x plus 5 to the -2 is x plus 5 to the -2 plus 1, or -1, divided by -1. And we're going to evaluate that from -4 to -2. Using your calculator, you get approximately 18.849. And now we can subtract volume of 1 minus volume 2, and that'll be the volume of the solid that remains. Okay, about 138.23.